So what is my slope of this graph? Good, 3 over 1. And what is the y-intercept of the graph? So on our graph here, I just like to draw out the x and y axes so you can see them. We're going to start at our y-intercept, which is 6. I'm going from there. I can't really tell. 5, 6. And then I'm going to do my slope, which is up 3 over 1. And I'm going to do that down 3 over 1 as well. So just make your long line. So that is our line. So hopefully you remember how to graph y equals mx plus b. If you're going for a positive slope, you always go up and over to the right. If it's a negative slope, it would go to the left. So positive slopes go to the right. From here, I'm going to tell you where our critical point is. So we want to identify our intercepts. So we know our y-intercept I've already identified. The x-intercept, we can now see it right here. What is that point on my x-intercept? -2. And this is identified as our critical point. So everything below this, I'm just going to make it in different color. Everything in blue is in the negative portion of my graph. So this is my turning point here. So anything below this point is negative. So I want to take those points and make them positive, because you want everything to be positive on this graph. So this is already positive, because this is my positive section, where y is positive. This is where y is negative, right? So we want to take these and make them positive. So we're going to go from our critical point, and we're going to do our slope backwards. So I would go up 3 over 1 in the opposite direction. Up 3 over 1. So I'm going from my critical point. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. So now I've taken the negative portion of my graph and I've now flipped it up to become positive. So this portion here, the blue, has now come up to here. You see that? Do it again. Blue is now turning to here. Yes?
So is the x-intercept always the critical point?
Yes. So if you're not sure, if you graph it and it doesn't go through a nice point like that, what I would do to find my x-intercept, if you couldn't actually see that it's -2, let's say it falls in between, you're like, oh, it's some decimal number, I don't know what that is, then to find the x, to find the critical point, you would put y equals 0 and then find x. So let's do that with our equation. So I would put 0 in for y. I would minus my 6. And then divide by 3. So that's also how you can get your critical point. Or if you're dealing with like a parabola, you would probably factor to find your x-intercepts, or you would use quadratic formula to find the x-intercepts, which I'll get into in the next example. So your final graph is this. So I'm just going to draw it in the black, kind of dark blue line, so you understand that this is your final graph. You can always graph the original straight line, you would just make sure you draw harder on the actual graph. So absolute values are going to look like this type of V form. Yeah? Oh, yeah, I'll scroll down. We also need to identify the domain and range. The domain is your x values, and they're going to be all real numbers. And then your range, for the most part, it will always be greater than or equal to 0. And that's because they're positive values. Is there any questions on that? So if you're not sure, I'm going to show you. Any questions on that one? And if that's okay, flip the page. Thank you. So what I'm going to go over right now, it's called piecewise notation. Okay? Piecewise notation. Third page. There you go. Third page of your notes. I'm going to go back to that in a bit. I just want to continue with the straight line stuff. Piecewise notation. This is used to describe the function that has different definitions for different subsets. And this is for the domain values. The absolute value number is often defined using the piecewise notation. So what do I mean by this? I'm going to have some absolute value function. So for example, the absolute value of x, just looking at x for now, it can be equal to two things. So remember how I talked about the absolute value up here on the board? You could have -4, which equals 4, and positive 4, which equals 4. So you could have absolute value of x, or you could have inside here negative x. So you could have two situations. Now, you're going to have two situations happening with your graph as well, because when I graphed this originally, I had this positive section here. Let's say the purple is positive. And then I had the blue, which was the negative section, right? And that's two different situations on our graph. So that's what you need to write about in piecewise notation. And you're going to say what the x's are defined as. So x would be positive when it's greater than or equal to 0. And x would be negative if it's less than 0. So for example 3a, I'm going to write out the piecewise notation for this type of graph. So this is very similar to what we just saw. So what I would do first is I would actually graph my 2x minus 1. So remember what I did was graph this originally. So how would I graph 2x minus 1?
2x, the x-axis 2.
What do you think? Anybody want to help Sawyer out?
Yeah, I need some help.
What do you think? Yeah?
Well, wouldn't the line be from negative?
Good. So y-intercept is -1, and then what would you do after that? So start with y-intercept. So I'm just going to make some lines here, and then I'll write that down. Slope is 2/1. Good. So we would start at -1, and then from -1 we do our slope. So we go up 2/1, up 2/1, up 2/1, over 1. So there's our line. Now, I want to find that critical point because that's going to be important to me. Because I can actually see what my critical point is. It might be 1/2, but I'm going to double check. So let's find the critical point. Because you're going to need that for your piecewise notation. So to find critical point, I'm going to put y equals 0 in and solve for x. So I would add 1. And then I would divide by 2. So my x is 1/2. So that's my turning point right here, 1/2. I'm just going to put a little arrow there, of where my graph is going to actually turn to become positive. So right now I'm going to show you how to write out the piecewise notation in relevance to my negative section, or my positive and my negative section. So I have 2 sections of this graph now. So the piecewise notation, we would write out y, I think this is okay here, equals, with a nice big curly bracket, and we're going to have, from our graph, inside the absolute value, I'm going to have the positive version, you're welcome to just write it like this, and the negative version. Do you see that? 2 parts of your graph, positive version and negative version. I'm going to underline this in green because I'm going to draw the positive version of my graph in green so you can see it. So hopefully this will make sense if I have green matches green. So if you're looking at the point, the critical point from our positive section, which is 1/2, what is happening to our x values with this graph from 1/2?
They're getting bigger.
They're getting bigger, right? Because they're going this direction. So that's what we need to say now. So my positive portion, my x values are getting bigger than our critical point. So x is going to be greater than or equal to, and I'm going to write this in green, 1/2. So that's coming from your positive portion and your critical point. Does everyone visually see that? So that's why I start by graphing it to actually see what's happening from my critical point with my positive section.
So this one too, not just like a little thing because it's like a half.
Like to move it to become positive?
Later on, that one uses like the.
That's, I did that because that specifically said graph it. I'm using this to help me write this. Yeah. But you would do that if it said graph the absolute value. You would do that.
How would we know what it is?
I would still go from 1/2 and go up to from the half point and over 1. Yeah. It would just be in the half sections.
Would that be a negative one then, though? Use that.
You missed the first example. Yeah.
Do some practice.
And then for the negative portion, I'm going to make it orange. So you can see this is my negative portion of my graph down here. Does everyone see that? Now what's happening with my x's in the negative portion? They're getting smaller, right? Because the graph is going this way, which means every x value is actually going to be like -1, -2, -3, and it's getting smaller. Okay, so this orange section is my negative, so that's going to be everything less than 1/2. So x will be less than 1/2. Also from your critical point. This one is always equal to, and this one is always not equal to. And they're always going to face the opposite way. Does everyone see that? Now if you had, I'm just going to do it on the board here. I think the other ones are parabolas, which I'm going to do tomorrow. But I'm going to show you one if it was a negative slope. Actually, yeah. Can I do, it's number 9 9A in the book, if that's okay, because it's a negative one. So I'm just going to get you to all pull out your books, and I'm going to put out 9. So my x values, I'm going to write this in this color, are going to be less than or equal to my critical point. Once you figure out that one, the second one is just the opposite. And it will be greater than 2. Which makes sense because if you look at this portion of my graph, I'm going to make this orange. You can see that from my critical point, what's happening with my x values? They're getting bigger than 2.
Wait, so for the positive, is it always like equal to the number?
Yes.
And then the negative one is just
Okay, so that's piecewise notation, and I just did it with linear graphs today. Tomorrow I'm going to do the quadratic graphs, so that's why I just did quadratic or linear. So for your questions today, because I think I wrote down, you're going to start with page 622. You're going to do 7A. Right, each absolute value function piecewise notation. 8A. I want you to just graph an absolute value as well. We just did 9A, so you can do 9B. I want you to graph one and 10A and B. That's it. Because those are just all linear ones. So these are 7, 8, you're graphing, completing the table if you want to, or you can graph it the way I showed you. 8, 8, and 9, you're doing the piecewise notation, and 10 is graphing. And then identifying the domains and intersects. Okay? There you go. It's not?
I have to do this for work
I
experience.
don't know either.
I was gonna like search up to see if I could find things online.